Hello, my name is Adam, and I'd like to take you on a tour of the history of computers. Computers can seem so futuristic. However, they have a very, very old history. And the reason the history is so old is because human beings have been counting for tens of thousands of years. And even as long ago as 4,000 years ago, we first started making machines to help us count and help us to remember the answers to the math problems that we've created. This is an example of one of those early machines. It's a Chinese abacus. The abacus consists of a series of beads on rods that can be slided up and down in order to perform adding and subtracting calculations. At the end of the calculations, you're left with beads in certain positions that can be counted or read. This basic concept hasn't changed much over time. And here's some examples of various abacuses from many different cultures on Earth. These are all very similar, but there was one oddball. The quipu from the ancient Inca Empire was a series of ropes with knots that allowed the user to record information. We know that it was used for census, for doing taxation, for counting grain output. Some scholars even think that language might have been stored on these ropes with knots. The first major change in computing actually happened at the dawn of the Industrial Revolution with the invention of the Jacquard loom. This is around 1801. The thing that makes the Jacquard loom so radically new in the history of computers is that it was programmable. It had these paper punch cards that a pattern could be stored on. If you notice on the paper, there are holes in different patterns along the card. As the paper scrolls through the machine, whether or not there's a hole there tells the machine whether or not to mix in a new color, to shift the loom in a certain way. This allowed the weavers to create programmable, intricate patterns with this machine. You can see here where different strands of thread intermingle. The intermingling is controlled by the pattern on the punch card. The reason you should take note of this punch card technology is because as computers develop, we need a way to store information on them and then run them through a program. Another leap forward in punch card technology was brought about by Herman Hollerith, who just before the 1890 census was commissioned to develop a machine to help the U.S. Census Department do its 10-year calculation of the number of people there are in the United States. This is a time when the U.S. population is changing quite rapidly, and the census wants to create additional data besides a specific head count. So if you can imagine, under each column here is a question. How many people live in this household? How many children live in the household? What labor does the head of the household perform? A census interviewer could come to each house and punch out holes in the card that represented the answer given by the household. These cards could then be taken home to a base station where all of the cards could be fed through a machine, and then the answer would be spit out. How many children are there in this city? How many pet owners? Whatever question they wanted to ask, it was possible to record a number on the card, put the card in a machine, and get an answer of the total. Here's an example of the original patent that Herman Hollerith filed. The work that he did went on to become IBM, a very important computer company in the history of computers. And it's also worth noting that some of this technology has a dark side. IBM and its subsidiaries did help develop similar counting machines or census machines that helped the Germans be very efficient in waging war, particularly the Holocaust, rounding people up through the use of these machines. War making is also absolutely at the heart of the rapid development of computing. During the Second World War, very many different code machines and code-breaking machines were developed in order to send secret messages. These examples that I'm flipping through, you don't need to know the details necessarily, but you ought to know that these machines could take our language, our written language, and convert it into nonsense using very complicated mathematics. You then needed to know another machine. You needed to have a cipher, another machine that was able to decode the nonsense and make it intelligible again. A lot of computer scientists and mathematicians were working on developing machines such as this one that would make it easy to decrypt or translate the nonsense into something intelligible when the enemy had the cipher and the Allies did not. And most important in the history of computers is the switch from mechanical computing to electronic computing. And this happened right here in Philadelphia. At the University of Pennsylvania, the ENIAC machine was developed. At the time, it was basically considered the first programmable digital, or the first programmable electronic computer. Here's some images of the women who helped build and maintain it. Here's a moody photograph of its usage. The reason these computers were developed was because with the development of rocket technology, the mathematics of having a rocket launch from one place and then land at a very precise location somewhere else are quite complicated to perform. It took several hours of computing time in order to figure these things out. Machines like ENIAC helped shrink the calculation time. They were able to perform these complex calculations. And as the war ended, companies such as IBM started to figure out new uses for calculating machines. For example, banking. Banks have to contend with large volumes of numbers, and machines such as this were used to record accounts on magnetic tapes that we see in the background and store some of the tapes here, and perform calculations at the request of the user at a terminal of some sort. But a big problem was when you had these large mainframe rooms like the one we just saw, a lot of data was stored in one place. If that place got destroyed by, say, a nuclear weapon, the information might be lost. The same would also be true of the communication system. If you took out a city, perhaps if New York City were hit with a nuclear bomb, it might be difficult to communicate from Philadelphia to Boston because New York exists between the two, and it would be difficult to route calls through. The Defense Department commissioned something called the Advanced Research Project Network to figure out how to build a computer communication system that would be indestructible or difficult to destruct if a certain piece were removed. So this is a diagram of the very first computer network linking San Francisco, Los Angeles, out to Utah. The network grows over time. It starts to include the East Coast. It gets denser and denser with the inclusion of the Midwest, more and more of the East Coast. The system keeps on growing, and eventually this is going to become the Internet. By 1977, we'll end up with this dense schematic of the early link-up of academic computers, military computers, into a network that was able to share information. This is pretty much going to be where I'm going to leave off with the history of computers, because we have some more explaining to do with about how computers today work and how the internet works. I look forward to talking to you in some future lessons. Thank you.